Okay, thanks very much for being here, as well as the invitation from the organizers. So I'm very happy to present actually the title has been changed a little bit, but I mean, the general idea is like this. So we're not going to discuss about the fundamentals of ChatGPT, but instead today we're going to talk about how we're gonna make use of ChatGPT, okay, in a practical way, based on a lot of like internal and external results done by our peer groups, by the colleagues, as well as by my group. Okay, essentially, I mean, everybody is familiar with ChatGPT. I do not want to introduce more. And in a high level, it is a large language model for mainly designed for dialogues, for conversational AI. And it has been extremely popular over the past couple of months. That's why we have done, I mean, based on our preliminary work, based on our previous investigations, we have done a thorough investigation on the capabilities of ChatGPT and how we can make use of ChatGPT in many downstream applications, especially those related to powering knowledge graph, such as today I'm going to talk about mainly named entity recognition and relation extraction, leveraging the capabilities of ChatGPT. And at the end, we're going to talk about some regulation, how we can really make sure ChatGPT will not create a lot of like mess or critical problems to the society. Okay, in the beginning, I'm going to talk about some like capabilities, advantages, and disadvantages of directly or indirectly making use of ChatGPT in some applications. So before doing that, a very quick overview of what ChatGPT can be done. I mean, just in case some of our audience, you are not super familiar with ChatGPT, okay? So firstly, we are able to use ChatGPT to write codes, okay? And this has been a very powerful tool because like at least in our investigation, I'm directing 2 projects. One is like how we can convert natural language into circle codes, which can be used for powerful business intelligence applications. Because in many BI companies, one of the most important applications is like, the marketing people, sales people, they would like to have a very quick overview of some very natural language questions, such as how many male in Singapore between 30 to 50 years old who are interested in digital products. And for this kind of very simple natural language queries, when they send this query to the data science team, often, I mean, because this is a low stake query and low impact query, that's why often data science team is a little bit reluctant to directly and very efficiently communicate. In this case, how we can really enable non-data science experts, such as those marketing, salespeople, can directly make use of the powerful large language model for the purpose of directly answering some BI questions. This is one application. Another application is, I can give you like several examples. Another application is like we are working on a healthcare project for patient trial matching. Because in Texas Medical Center, we have patients from all over the world, okay, flying to Texas Medical Center for example, MD Anderson, which is the best probably hospital treating cancer. And however, I mean, many of the cancer patients, unfortunately, they are in the later stage, okay? And there's no very effective treatment. That's why they would like to participate in some like trials, clinical trials. But I mean, there are like just too many clinical trials for them to participate. That's why, how can they effectively, efficiently communicate with trial coordinators such that they are able to be admitted into those trials to save their lives? So super important applications to make use of ChatGPT to write codes. And there are a few other examples, such as like we are able to make use of ChatGPT to answer some general questions, such as to give a brief introduction about yourself, and how we are able to make it more formal by enforcing some interaction, which is a little bit different from traditional search engine. I mean, by inputting a query and receive some like factual answers. So very different applications. And in terms of the technology fundamentals, ChatGPT is a sibling, can be considered as a sibling model to instruct GPT, and which is trained to follow an instruction in a prompt and provide a detailed response. You can see based on this same prompt, the outputs from GPT-3 and instruct GPT, they're pretty different. And compared to traditional models, if you consider GPT-3, GPT-2, these classical language models as traditional models, okay? They are not that traditional, okay? They're not too old, but still, ChatGPT generate much more helpful outputs in response to user instructions and very easy to understand by human beings. That's why it has been very impressive performance of ChatGPT. And before going further, I would like to talk a little bit more about how we can train a ChatGPT and especially based upon the development and the design of GPT-3. Roughly, it can be categorized into 3 steps. And also, I believe many of you have heard of the term reinforcement learning from human feedback. And this is a technique how ChatGPT could perform more like a human being based upon already very powerful large language models. And in the very first step, the key is how we can collect human written demonstrations on prompts submitted to the API and train supervised learning baselines. Essentially, the very first step is we need to sample from our prompt dataset about 1 prompt, okay? And then a labeler, a human labeler. This is basically an unemployed user, okay? We have to label we have to demonstrate the desired output behavior. So basically we need to carefully somehow design a prompt that can be used for some applications. And this data will be used to fine-tune GPT-3 model with supervised learning. And that's the very first step. And the second step is to collect the human feedbacks and then train a reward model to predict the human preferences. This is the key of how we can make use of human feedbacks for training an effective reinforcement learning model. And oops. Guess I need to click quit. Okay. So a prompt and several model outputs will be sampled, and then they will be ranked by the human labeler. Basically, the labeler needs to decide which output will be better than others, such that they are able to provide human knowledge to guide the training of the reward model, which is the key of this reinforcement learning framework. And the third step is to optimize the policy against the reward model using reinforcement learning. And specifically, a new prompt is sampled from the dataset. The policy generates an output, and the reward model calculates a reward utility numbers for the output. Then the reward will be used to update this policy using a very popular reinforcement learning algorithm called a PPO. So through these 3 steps, the key here is feedback, human feedback will be happening in 2 phases. The first phase is a labeler demonstrates the desired output behavior, and the labeler needs to provide some examples to tell the ChatGPT, to tell the language model. So what kind of output we are looking for. And then later on the second step, the labeler needs to rank the outputs from the best to worst, such that it will determine what kind of preferences we are looking for, such that a reinforcement learning function can be learned, okay? So these are pretty much a high-level idea how ChatGPT can be trained based on the traditional language models, and why it performs very well by leveraging the human feedback. And because of the popularity of ChatGPT, many people will think, oh, ChatGPT is so powerful and very effective. How about we just directly make use of ChatGPT in our downstream applications? And to validate the hypothesis, to see whether ChatGPT can be directly used in many applications. We have done several experiments. Oh, sorry. So these experiments are not done by us, by my group. Here I use we in a general way to represent the community. Okay, we have done a lot of experiments to see the performance. And from this table, we can see this is a text summarization task. And we have compared the ChatGPT with fine-tuning models on multiple data sets using different types of metrics. The higher, the better, okay, for those metrics, basically. As we can see from this table, by comparing ChatGPT with fine-tuning results, in general, ChatGPT achieves comparable performance, traditional fine-tuning methods. They fine-tune the model in some general datasets in the news domain. So in general, it performs not bad. It's okay. And in some specific domains, it even performs better. But in general, ChatGPT tend to perform a little bit lower performance. That's a general impression. Okay, another task, machine translation. So please remember, here we don't do anything on top of ChatGPT. We just use a vanilla version. Okay, and another task is machine translation. And we compare ChatGPT with Google DeepL Tencent translators, machine translators, on multiple different language. For example, D to English, RO to English, Chinese to English, and so on. Okay, different types of languages. And as we can see from this table, in general, ChatGPT is comparable to many commercial systems in translation tasks with rich corpus. Rich corpus means we have a lot of resources. Last presentation we introduced, in another presentation, I got messed up, sorry. So rich information, rich corpus here means we have a lot of information, such as English to Germany. It performs very well. However, for some low resource corpus, such as Romanian to Chinese, we may not necessarily have a lot of data sets available to train this ChatGPT at the time of training ChatGPT. That's why it performs not very well, not ideal, comparing to many commercial systems, in which I strongly believe they have done a lot of fine tuning, okay, for the specific language translation. So what is the conclusion? I mean, still the results are not comprehensive yet. However, we can make some I do not want to say it's conclusion. I would prefer to say this is more observation. So we have some use cases and non-use cases. Means we have some recommendations and not recommendations. In general, ChatGPT should be be used on some creative and complex tasks, including, for example, coding and writing assistant, and so on. Okay, it needs a human involvement a lot. And it is very suitable for tasks with limited or no labels. As you can see, ChatGPT performs very well in zero-shot and or few-shot learning. Okay, I would like to make an analog here. So considering ChatGPT is you want to hire a chef for your home, okay? And for this kind of ChatGPT style chef, it can provide a reasonably good food for any cuisine, okay? If you like Chinese food, Indian food, Singapore food, and whatever food, Italian food, so the chef will immediately give you some a very good cuisine, no problem. However, if you compare this chef with a dedicated, for example, Italian chef, it may not perform that well, okay? Simply because this chef is too general, and it consumes a lot of knowledge, and it has a lot of experience on all of the tasks. And that Italian chef, he may be dedicated to this task for 30 years, super experienced, but very vertical. That's why for tasks with limited or no labels, fine-tuning a smaller model is typically challenging or impossible to match GPT-3 is 0, 1 few shot performance, meaning like if you want to this Italian chef to cook a Chinese food for you, that will be very problematic. Okay, no way to compare with ChatGPT in general. And some other tasks, knowledge-intensive tasks, while retrieval is not feasible. For example, close the book question answering, or some like scenarios we may require mimicking humans. For example, chatbot, for example, gaming applications. So for these applications, ChatGPT tend to be much more preferable comparing to other like dedicated models. And actually the budget is very low. And ChatGPT is not like perfect, for sure. It cannot be applied to all tasks, and it has its own limitations. So very first one, the reason why I deleted this one is like yesterday, ChatGPT just released their API fee structure. It turned to be like they have paid a lot of efforts to make it much more affordable than before. Okay, that's why calling ChatGPT API is out of the budget. I mean, for most of the applications, it's not a big problem anymore. That's why I purposely like rip it out. However, the other two problems still remain, and they are critical problems, especially in the community. The first one, if your data is very sensitive, it contains like privacy security issues. Still, ChatGPT is not ideal because currently, unfortunately, OpenAI is not that open. Okay, it is not designed the way comparing to its like initial purposes to be open. It's still closed source. It's for commercial purposes. For many applications in hospitals, I do not want my patient data to be scanned by OpenAI. In banks, in commercial systems, I do not want my financial data to be scanned by OpenAI because I do not want these high-stake applications to be possibly ruined by OpenAI's like strategies. Okay, because I never know what my data will be used for, whether this will be directly integrated or partially integrated into the training of the system, whether or not some of my patient data will be repeated in the future answers to another problem. So I cannot afford this risk of leaking my data. That's why for this kind of tasks, no ChatGPT, no way, okay? And or I already have a very good Italian chef. Okay, I do not, and I only like Italian food. I do not need any other food. I already have a very well performed, fine-tuned smaller module with high accuracy, very high accuracy. There's no way for a general model like a ChatGPT to outperform this kind of smaller but fine-tuned model. Okay, that's why in this case, this kind of large language models still they are not suitable. Some like conclusions. ChatGPT has shown exceptional performance in various language-related tasks, outperforming the state-of-the-art zero-shot models. And that's no doubt, okay, comparing to many other competitors released by, for example, OPT or even for Flan T5, this kind of very effective language models. So ChatGPT is the best. Okay, when compared to fine-tuned models, ChatGPT is not perfect. Okay, it cannot be used in all of the tasks for sure, and it faces privacy concerns, privacy security concerns, and surely there are some like other alternative solutions. And I'm working very closely with several startup companies to develop like vertical solutions, how they can be deployed, making use of the open source solution for vertical companies. Second one, I would like to specifically discuss about several downstream tasks, how to better leverage ChatGPT instead of directly asking questions to ChatGPT, which is not its strength, okay? Here, specifically, I would like to talk about clinical text mining, about two specific tasks, also related to knowledge graph. That's why I try my best to make a connection to this workshop, okay? The very first one is like name entity recognition, and the second, relation extraction. And here I show a very quick example. A 44-year-old man taking Paxlovid, experiencing hives and many other symptoms. So in this sentence, the goal of name entity recognition is to identify, okay, there is a drug name Paxlovid, and there are some other symptoms. So these are like name entities we target to extract. Another relations is like for some of the for the medication, it will result in some like treatment for some symptoms. So these are like relations we target to extract. So these are the two main applications we want to discuss today. And here my students also tried some examples. We design specific prompts to guide ChatGPT adapt to the task. And we tried a lot of efforts to try to do the prompt engineering, try to like adjust the prompts to be better and better, such that we are able to extract the name entities as well as the relations. However, okay, here is like we have done preliminary results, which indicate that employing ChatGPT directly for these downstream tasks, resulting only very average performances, especially comparing with, I mean, even comparing with other like language models trained on those like specific domain data. So here we conduct the two tasks, NER and relation extraction on two data sets respectively on NCBI and GAD data sets. And we compare the performance of ChatGPT with BioBERT, which is a pre-trained model on bio-related literature data. And here are like three metrics regarding precision, recall, and F1 score. And as you can see from the comparison, so we have tried very hard to design the best prompts, how to engineer the best prompts. However, still, from the data set, from the table we can see, so ChatGPT like the performance is far away from BioBERT. Okay, it's not even close. That's why the kind of the first intuition we have experienced here was like, oh, so yes, for some like general tasks, ChatGPT probably is very powerful, but unfortunately cannot be directly used. Okay, it's not even comparable to like some like traditional models. That's why we were thinking very hard. So how to leverage the capabilities, the powerful capabilities of ChatGPT for those tasks. And to do that, we design another way. We try to indirectly leverage the effectiveness of ChatGPT for some like downstream tasks. And here we come up with it seems like a too complicated framework. But it is not that complicated. Okay, let me explain it to you. So the first one is like we have some like a task description. We know this task. So it's either like name entity recognition or relation extraction. So the very first step, it is like we want to like generate a vast quantity of high quality synthetic data. So basically we want to leverage ChatGPT for generating synthetic labeled data for these tasks. Because for the two downstream applications, for NER and relation extraction, both of them, the bottleneck was not the model. The bottleneck was the labeled data, the label information of those data, especially given a new task. That's why we were motivated. Oh, so some people, they directly ask ChatGPT to extract the entities and the relations for the testing data. But instead of doing that, we don't do that. What we did is like, oh, how about we ask ChatGPT in some way to generate some similar in-distribution data comparing to the tested data, such that we are able to build up some like label information. And making use of the label information, we are able to train a supervised model, which follows similar, if not identical distribution to the testing data. And such that there are two very nice characteristics, properties. One is like we are able to leverage ChatGPT for labeling the data for us. Second is like this label information can be directly converted into knowledge and integrated in the downstream application model. Specifically here, it is like name identity recognition and relation extraction. That's why from this framework, the very first step is like how we can conduct a prompt engineering, such that we get some like candidate prompts, and which will be, optimal prompt here is not really optimal because it can always be improved, okay? But through this like circle, we identify some like, we try our best to identify some optimal prompts, which will be used to generate some like, which will be inputted into ChatGPT to generate some synthetic data. Such synthetic data, they contain label information, and they can be used as a label data to train a supervised model, which turn to be very effective. Okay, this is kind of an innovative way of using ChatGPT for downstream tasks, which cannot be done directly before. I hope this makes sense to you. Okay, and here is like we show one example of the synthetic data generation from ChatGPT. Which will be able to generate high quality and undistributed labeled synthetic data. Okay, here we show an example. We create so this is a prompt. We tried very hard. Okay, we manually created this prompt, and with a lot of like somehow experiments, and we generate 3 positive examples followed by 3 negative examples for the gene disease relation extraction task. In one table with head like this, and then the target gene is described and like this. So the prompt engineering is based on our understanding of this task and the data set. It is based on our experiences, and it has to be done manually by data scientists plus domain experts. And otherwise, there is no way to generate a very well-organized, high-quality label data like this. But this is kind of the way how we are able to better leverage the capabilities of ChatGPT to generate high-quality data for us. And it turns like we have very good, you may not necessarily only generate 3 positive examples and 3 negative examples. So we generated thousands of like positive examples and negative examples, such that we are able to make use of this label information to train a very effective like supervised model. And then let's take a look at the model performance afterwards. Okay, you can see for NER task and relation extraction on the 2 data sets respectively. With this generated data, so we are able to achieve very good performance comparing to vanilla ChatGPT. It means like we directly ask ChatGPT to identify those like name entities and relations. Okay, we are able to like achieve much better performance. And actually, I would like to mention another very nice property here. By doing the synthetic data generation, thinking about this, we do not need our testing data, or we do not even need our true data to be scanned by ChatGPT. Remember, one of the challenges I mentioned before was like we do not want sensitive data to be scanned by ChatGPT, right? For the purpose of privacy preserving. And by doing this, thinking about the whole pipeline, in the whole pipeline, we only need to make use of our expertise to engineer the prompts instead of directly feeding the data to ChatGPT to ask questions. And by doing this, we avoid the problem of potential leakage of our data to ChatGPT. That's why we do privacy preserving, and we also leverage the capabilities of ChatGPT. Third, we also improved the performance. That's why the results show that local model trained on the synthetic data outperforms ChatGPT performance very well, which is already very high baseline because like ChatGPT, in terms of the 0-shot performance, it achieves like the best performance comparing to other generic models. And also, we do not have to worry about the expensive and time-consuming data collection and labeling, because essentially for synthetic data generation, we can do unlimited data, okay? We can do whatever any number of label data we want in distribution data, label data. So very well. I still have roughly 5 minutes. So at the end, I would like to introduce another line of work done by my group, which is like to tackle the problem of regulation about the concerns of misuse of ChatGPT in some like especially educational community. As we know, including like some like schools in the United States and Hong Kong, so they banned the use of AI chatbot, specifically target ChatGPT because of its like premium performance in using ChatGPT to write essays and answer questions. They do not want ChatGPT to like ruin the education system. They do not want the students to take the shortcut instead of training their own writing capabilities, or instead of like they learn a lot of knowledge by themselves, but they rather seek help from ChatGPT. And to tackle this kind of problem, it's still like debating, okay, how we can better leverage ChatGPT in educational systems, okay? But this is out of the scope, beyond the scope of our talk. But here we want to say, okay, to prevent the misuse of ChatGPT, what we can do as a computer scientist. So here specifically, what we want to do is like, are we, to answer the question, are we able to detect the machine-generated texts? Are we able to distinguish whether the texts are generated by ChatGPT or human beings? Okay, this is a question we try to answer. Simply because of these like premium capabilities in generating human-like texts. And from the perspective of end users, large language model generated text detection could increase trust in natural language generation systems and encourage the adoption. So from the machine learning system developer and the researchers, it can aid in tracing generated texts and preventing unauthorized use, such as a violation of intellectual property. That's why, and also thinking about this from the user perspective, we want this can be detected. From developers' perspective, we want this to be better adopted. That's why OpenAI has the incentive of doing this. And from the content creator perspective, we want our intellectual property to be properly protected. That's why almost all of the stakeholders, we are on the same page. We want to identify whether or not this text is generated by machine. But specifically how to do that? Here, I would like to give you a very quick and high-level introduction. So basically, all of the technologies can be divided into two categories. One is called a white box detection, and the second is like a black box detection. White box here is it's like a security terminology. White box means like it's the model is transparent to everybody. Okay, so we have access to the model, and that's why we know what's going on inside this model. Black box means like we do not know the model. Current situations like OpenAI does not open source ChatGPT. That's why it is a black box model. And for OpenAI, because for OpenAI researchers and developers, they have access to the model. That's why it's like a white box to them. And also for open source systems such as OPT, Flan, T5, all of these systems, they are like a white box to us. Okay. Hopefully the terminologies are clear. For a black box, so if we do not have access to the model, such as how we can detect the texts generated by ChatGPT, currently we do have some like solutions. For example, there is one detector released called GPT-0. Mainly the high-level idea is like there are some language patterns contained in the machine-generated texts comparing to human-like generated texts. And I can give a high-level example here would be, okay, so for machine-generated texts, they tend to use some specific words. If we use a simple example to demonstrate, okay, they tend to use some like specific words. And for humans, they tend to be more sophisticated in using more coverage of words. And in terms of like perplexity and proportion. So you can see the distribution of ChatGPT generated texts are very different from human generated texts. Although as a normal user, we are not able to distinguish. However, using programs, using statistical information, we are able to detect whether this text is generated by ChatGPT or not. And this is a black box model. We don't touch the model itself. We do post-processing, okay. And for white box detection, the detector has full access to the target language model, allowing the embedding of secret watermarks into its output for monitoring any suspicious or unauthorized activity. So you may be a little bit confused about what do you mean like a watermark to language. A very simple way. So here is like there are many sophisticated ways, such as the one I presented in this slide. A very simple way is like we maintain a whitelist and a blacklist, okay? And for all of the generated texts, we just go through one more post-processing step, and we just simply change. So for all of the words in the whitelist and the blacklist, we have a one-one mapping. For example, car and auto and vehicle, okay, or our iPhone and the phone, or some like some words with similar meanings, and we use like the words in the whitelist to substitute the words in the blacklist. And then the output will have a very interesting phenomena, observation, because they don't use any words from the blacklist. Then it will be very easily detect whether or not the text is from the machine, or because it goes through the post-processing, and it's easy to distinguish. But for more sophisticated methods, we can say like still, we can use a green list and a red list. And this is no watermark, meaning like this is generated by humans. It's written by human beings. And that's why we tend to use different types of words. But if it is like generated by the machine, okay, because of the green list and the red list, we purposely only sample words, or preferably sample more words from the green list. That's why for the text generated by the machine, they tend to show watermark like this. Okay, they tend to show a lot of like words sampled from the green list and very little from the red list. The more green words, it means like the more it is more likely to be generated by the machine. I hope this like makes sense. And this can be done by OpenAI because they have access to the codes. This can be done by developers who made use of the, for example, open source the language models to generate the texts, such as OPT or FLAN-T5. Okay, these are the technologies used. And we do have concerns about large language model generated text detection. So here are some conclusions. These are like takeaways, okay. Black box model detection works very well for now, okay, even for ChatGPT, which is considered as the best text generator. So for now, no problem. No matter it's white box, black box, all of the technologies, we are able to handle the detection. However, with the technologies evolve, okay, when ChatGPT Plus or ChatGPT plus version come out, it becomes more and more sophisticated. The black box model will not work anymore, because I mean ChatGPT will try to mimic the distribution, will try to be even more sophisticated to fool people, to fool the detector, and tend to be more human-like. And in that case, black box model will fail in the future. Okay, so let's try to remember the timeline. For now, black box models, white box models, no problem, perfect. Okay, in the future, black box models will not work, trust me. Okay, and the white box models in the near future, no problem, because like because for many models, normal users, we don't have access to the models. We don't have our own ChatGPT, no problem. However, in the longer future, the major concern of this domain is like if normal users or normal companies, they have full access to the model. For example, if after ChatGPT plus, they are open sourced, and everybody can remove this kind of watermark from their own generating algorithms in the longer future. That will be very problematic, and there's no way without a watermark to detect whether or not these texts are generated by the machine or human beings. So hopefully, so one more time. Now, no problem. White black box models all work. In the near future, black box models will not work when we have an advanced version of large language models. In the longer future, my concern is like if we have a super powerful open source model, this will create a mess. Okay. But fortunately, so don't lose hope. Don't lose hope. Okay. Fortunately, everybody recognizes this is a problem. OpenAI recognizes the problem. The government recognizes the problem. And we normal users, we recognize this a problem. So in the future, there might be a case, because I can still remember when I was a little one, my parents told me, okay, you have to like work very hard in handwriting. Okay, you have to like write very well. But now, I mean, that day in my office, I tried very hard to like find a pen. I don't have a pen in my office. I don't need to handwrite anymore. Maybe in the future, large language models will serve a tool to completely transform our society. That's still possible. We don't need to worry about whether it's human generated or human written or machine generated. So that will not become a concern anymore, right? So I don't know. So I don't know what will happen after 20 years, but I mean, technology-wise, we do have some concerns. Okay, thanks very much. And most of my results are from this, like two of our recently published papers, just in case you are interested in some more detailed results. Yeah, thanks very much.